Hi, we're going to be working on topic 6.7 and 6.8 today and tomorrow. So this is kind of a 2-day lesson, so we're not going to do this whole set of notes today. So the essential question that we're going to be answering is how do you integrate an indefinite integral? We've been working on definite integrals up to this point. So I can integrate a basic indefinite integral, okay? And then there's lots of I can't see. There's lots of things we're picking up in this lesson. I can integrate a trigonometric function. I can integrate an exponential function. I can integrate 1 over x. I can use the fundamental theorem of calculus to integrate a definite integral. And I can use the fundamental theorem of calculus to integrate the short method when the chain rule is present. So those things will hopefully all make sense by the end of this lesson. We're going to do this video, the first few examples. So there's this little activity here. And basically what we want to do is we want to find a function whose derivative is this. So remember, when we're doing a derivative, we bring the number to the front and we subtract 1 from the exponent. So to reverse that, we would have to take that 3, put it back up, and then in order to get back to the original function, we actually divide by the new exponent. So we would have 3 over 3, which would just divide it back to the new, so it would be x cubed. So, but we don't know, have we had a constant here? So we could have had plus 3, we could have had x cubed minus 4, we could have had x cubed minus 1/2. There's lots of different things that we could have put there, and when we bring it to the front and subtract 1, we would have had a 0 in this spot. So turns out there's lots of different ways. All of these things here are examples. So when we go back to do this, when we integrate, we always add a plus c at the end because we don't know what that value is. We can't get that value back without more information. So when we do indefinite, we in general just put a plus c at the end. So the integration symbol is certainly not new to us by now. Instead of writing what function would have had the derivative f of x, we write the integral of f of x dx, which is read as the integral of f of x with respect to x. Generally, we say that f of x with respect to x dx equals the antiderivative f plus c. Note, you must always write plus c after your integral's answer. So we have some basic integration rules. When we're integrating 0, it equals a constant. When we are integrating a constant, it is the constant times x plus c. If we are integrating a constant times a function, we are allowed to bring that constant out front. Okay. As always, when we are adding 2 functions together, we are allowed to split them up. When we are subtracting 2 functions, we're allowed to split them up. And this is what we call the power rule. So with the power rule, what happens is, say I have the integral of x squared. What this is saying is we are going to add 1. So when I integrate it, I add 1. So it'd be 3, and then I'm dividing by that new exponent, and then plus c at the end. So let's go ahead and try a few of these super basic ones, okay? So we have an exponent of 1 right here. We're going to add 1. So we've got keeping that constant 3x to the second, and then I'm going to divide by the new exponent 2 plus c. Done. This here I can't do yet because it's in the denominator. So I'm first going to start by bringing that exponent upstairs. Now I'm going to add 1. So we've got x to the negative 2. I'm going to divide by my new exponent plus c. I don't really like the way that looks. So typically I would bring that variable back downstairs. And sometimes they'll float that negative out in front. Again, I'm going to do a little bit of rewriting first. Okay, so I'm going to rewrite this as the integral of x to the 1/2 power, because remember, square root is the same as 1/2 power. I'm now going to add 1, but our 1's going to look like 2 over 2. So we've got x to the 3/2. I'm going to divide by the new exponent. Now, this new exponent we don't like it the way that looks, so we would multiply by its reciprocal to get it into the right shape and into the front. So that would give us 2/3 x to the 3/2 power plus c. All right, d I really don't like the look of. I'm definitely going to rearrange that a little bit first. First, I'm going to rewrite this as x to the 1/3 power times x minus 4 dx. Then I'm going to distribute this in. So that gives me, remember this is 3/3, so that gives me x to the 4/3 power minus 4x to the 1/3 power dx. Now I'm ready to integrate. So remember, we're going to add 1. It's going to be a fancy 1. So 4/3 plus 3/3 would be 7/3 minus, I'm adding 3/3 again. So x to the 1/3 plus 3/3 would be 4/3, and then always plus c. And it's okay to actually leave it like that. We do not need to take it back into the root-like answers. Okay, looking at this next one here, I'm going to rewrite a couple of times. So we've got x plus 1 over x to the 1/2 power dx. The next thing I'm going to do is I'm going to split that into 2 separate fractions, which I'm allowed to do. And now I'm going to simplify this one here by subtracting my exponent. So I know that that's 2/2. So I would end up with x to the 1/2 power. And then to bring this upstairs, we make the exponent negative. And sorry, I should have written smaller. I'm now going to go ahead and add my 1. So my fancy 1 would be 2/2. So we'd have x to the 3/2 power. I divide by the new exponent, or I multiply by its reciprocal, is kind of a shortcut. And then I'm going to do the same thing, add 2/2. So we would get x to the 1/2 divided by 1/2, or multiplied by its reciprocal 2/1 plus c. And you could drop the over 1 part. All right, I am going to rewrite this one a bit. So I really want to think of this as t squared plus 1 times t squared plus 1. We have to FOIL that, dt. All right, I'm not integrating yet. I'm going to FOIL. So t squared times t squared is t to the 4th. T squared times 1 is t squared. Another 1 times t squared would make us have 2t squared in the middle. And 1 times 1 is 1 dt. Now I'm going to integrate. So we've got t, I'm adding 1, so t to the 5th divided by 5, my new exponent. Then I've got 2t, I'm adding 1 to the 3rd divided by 3. I would just, when I integrate the 1, I just get a t, and then always plus c.